right, this video is for Unit 6, Lesson 1 notes. We're starting with trigonometry, so we're starting with angles. So the word trigonometry means measure of angles. We will start trigonometry by setting the ground rules for measuring angles on a coordinate system. So rotating a ray about its endpoint determines an angle. Okay, so say we have a line coming out like this. So from the x-axis to where that line is, that area, there's an angle formed by the x-axis and that line. And we use theta, okay? So that is the Greek letter theta, and that's typically used to represent angles, okay? So the starting position of the ray is the initial side. So this is the initial side. And the position after rotation, so that's this side, is the terminal side. An angle is in standard position if its vertex, so that's the point, it is at the origin and its initial side is on the positive x-axis. So that's a standard position angle. All right, a counterclockwise rotation generates positive angles. So as we rotate this way around the origin, we're creating positive angle measures. A review of quadrants really quick because you will need to know this. This is quadrant 1, 2, 3, and 4. A clockwise rotation generates negative angles. So if we rotate this way, our angle measures would be negative. And again, just remember your quadrants 1, 2, 3, and 4. Okay. Angles that share the same initial and terminal sides are called coterminal angles. So if we have like this, right? We've got this angle here. Okay, whatever the measure of that angle is. Or if I go this direction with it, so same line, but from here and around, that's an angle measure from the x-axis all the way around. So it would be a negative measure, but that angle. And then we could do something really crazy here. Say we go from here, from the x-axis, and we go all the way around and back to the angle, or back to the line. Okay, so all three of these angles are coterminal. So same pieces, it just the measure of the angle is going to depend on how we draw it. Okay. So it says trace a circle. So we're talking radians now. And label the center, it should say, of the circle. Try to be precise as possible. Draw the radius of your circle. Cut a length of yarn equal in length to the radius. Lay the pieces of yarn against the edge of your circle, creating an arc. Starting from the radius you sketched, draw another radius to the end of the arc of yarn. So I'm trying to think how I'm going to do this. Okay. How I'm going to do this, I'm just going to draw a circle, and I will have y'all do the same in class just to get it started. So I'm going to use the inside roll of this tape because it's close to what she's got on hers. So we're just going to go off of her measurements. Okay. So we're going to draw in the center. Okay. Normally when we do this, we use a compass to do this, a compass and a straight edge. So you get a nice pretty circle. Okay. So we've got a circle here. All right. So what does the angle you sketched just represent? So we're going to say it's 1 radian. Okay. So the whole circle is 360 degrees of rotation, or we can say 2 pi. Okay. A semicircle would just be pi. Okay. And then the degrees of rotation is 180 degrees of a semicircle. Okay. I know it doesn't make a lot of sense now, the pi and the 180, just I think you'll catch it. So what does this signify? So 360 degrees in angle measure in degrees is equal to 2 pi, or 180 degrees is equal to pi. And this is converting degrees to radius. That's what this is setting up. So the relationship to go from degrees to radius, we would take the angle measure, so again, theta degrees, whatever it is, and we can multiply it by pi over 180. And that's going to give you the angle measure in radians. You should have done this in high school geometry. I know you guys probably didn't. Okay, radians to degrees. So if our angle measures in radians, so notice I have a degree sign here and I don't here, we would do 180 degrees. So I should have put the degrees there to signify that. And divide it by pi. Oh, not equals, should be multiply. Multiply by that. And that's going to equal the angle measure in degrees. Okay. If an angle isn't labeled, it is assumed to be radians. If it contains a degree symbol, then the angle is in degrees. So you always look at the labels and really make sure that you're labeling your angle measures. So if your angle is measured in degrees, make sure you're putting that degree sign. And then if it's in radians, you don't put it. And that's how you recognize what measurement someone has used. Okay. Okay. So sketch the following angles in standard position. If the angle is in degrees, convert to radians. If the angle is in radians, convert to degrees. Leave your radian answers in fraction form. So for me, and again, this is stuff you should be familiar with. These are kind of our basic angle measures, but you guys probably haven't seen this before. It's easier for me to graph in degrees than it is in radians. So anytime I had something in radians, I would go ahead and convert it. So this one I'm going to multiply by 180 over pi. So what happens here and why we do this, the pi signs are going to cancel out. Okay. So 5 times 180 is 900. And then again, remember these pi's are canceling out over 7. And then if I simplify it down, I'm going to get about 128.57 degrees. So think about your measurements here. If I start at the x-axis, if I go to the y-axis, that's 90 degrees. If I go back to the x-axis, that would be a 180-degree angle. Okay, so this one's going to be about in the middle there. Okay, and so that would be that angle. Okay, again, make sure you're putting the degree sign. All right, so 2 pi over n multiplied by 180 over pi. I'm going to get, actually, I'm going to cancel out here. 180 is the same as 9 times 20. So these 9s will cancel out. These pi's will cancel out. 2 times 20, 40 degrees. Okay, so 40 degrees. So half of this one would be 45 degrees. So a little bit less than half, sorry, would give me that angle measure. Okay, so notice here, it looks different, but there's no degree symbol. So I would still take this, because that is still in radians, and I would multiply it by 180 over pi. Okay, simplifying it down, typing it in my calculator, I would get 279.60 degrees. Okay, so 90, 180, 270 would be coming all the way back around here. So a little bit further than 270 would be my angle. Okay, so that's radians to degrees. Let's go the opposite way, but these we should be able to graph. So 425, I would go all the way around. That would give me 360. And then 360, so let's look here. 360 minus 425. That tells me how far I need to go. Another 65 degrees. So going all the way back to the y-axis. So if I do this, I'm at 360 degrees. Okay. I need to go just another 60 degrees. Okay. So that means, and again, this isn't based on accuracy of any sort, that this is the actual method. It's just an attempt. It's close. Okay. So now we need to go the other direction. We need to turn this into radians. So this one, what I would do 425 over 180. I'm going to leave pi out of it in my calculator. I'm just going to do 425 over 180 and see if it simplifies. It does. And so this one is going to be 85, and then I can just tack the pi onto the top over 36. That would be the radian measure. Okay. Okay, so 320 degrees. So we know all the way is 360, so just not quite all the way around, and that would be that angle. And then 320 times pi over 180. Okay, so for this one, I'd cancel the zeros out. Those zeros will cancel each other because that's 32 times 10. That's 18 times 10. Okay, and then 32, I could do 8 times 4, or 8 times 2 times 2, and 180 would be 2 times 9. So this 2 and this 2 would cancel. 8 times 2 times pi is 16 pi over 9. And the last one, 128 degrees. So we know back to here would be 180. So we would be somewhere in here. And then 128 equals pi over 180. This one I'll just simplify for you. It's going to be 32 pi over 45. But you need to know how to convert from degrees to radians. Okay? All right. Next up. If the terminal side of an angle lies along an axis, the angle is called a quadrantal angle. So quadrantal angles in radians, this would be 0, 2 pi. This would be pi. This would be 2. Actually, it's pi over 2, sorry. Pi over 2. And then this is 3 pi over 2. And then in degrees, again, 0 degrees or 360 degrees, 90 degrees, 180 degrees. And so that's just saying if I go to this line. Okay. And these are kind of your basic measurements that you need to know, you need to memorize. Okay. So angles that share the same initial and terminal sides are called coterminal angles. For the angles listed below, give two angles, one in clockwise direction and the other in a counterclockwise direction, that are coterminal. Okay, so 144 degrees is going to be somewhere in here, right? 144 degrees. So the coterminal angle of this, meaning it's starting here, it's just going to go the other way. What would its degree be? What we can do is we can take 360 and we can actually go the other way. We would do 144 minus 360 because it would be negative. So negative 216 degrees would be one coterminal angle. And then we can also add 360, saying we go all the way around and then back to this place. Plus 360 would be a 504 degree angle. All three of those would be coterminal. Okay. 335 degrees would be out this way. So again, this would be the 335. So we could subtract 360 from that, and get negative 25 degrees. So that would just be going from here to here would be a 20 or a negative 25 degree angle. Or we could add plus 360 would be a 695 degree angle. And that would be if we went, it's going to be kind of hard for me to show this, all the way around and then back to where that line would extend out. That would be the 695 degrees. Okay, so doing this in radians, again, I always convert. But what you would be doing in this one, 2 pi over 5, we would be adding 2 pi. So to add 2 pi to this, it needs a common denominator. I can multiply this by 5 over 5, which would give me 10 pi over 5, which would give me 12 pi over 5. So that's one coterminal. Or we could subtract it, and I don't have to convert it again. I can just leave it like that. So 2 pi minus 10 pi would be a negative 8 pi, and just keep the bottom. Okay. So for 4 pi over 3, oh goodness, 4 pi over 3, I would need to add 2 pi, but again, I need a bottom of 3. So that's multiplying the top and the bottom. So that would be 6 pi over 3, which would be 10 pi over 3, or 4 pi over 3 minus 6 pi over 3. 4 minus 6 would give us a negative 2 pi over 3. All right, we're getting there. One more page. Okay. What rule could you make to find coterminal angles? So for the clockwise direction, we can subtract 360 or subtract 2 pi. And it can be, we can do this multiple times. So we just found a few of the coterminal angles. There's more than that. And so for the counterclockwise direction, we can add 360 or we can add 2 pi. All right, complementary and supplementary. Two positive angles are considered complementary when they sum to pi over 2, that's 90 degrees. They are considered supplementary when they sum or they add up to 180 degrees. If possible, find both the complement and the supplement. So if it's 40 degrees, 40 plus x has to equal 90, which means the complement is going to be 50 degrees. Okay. How I would teach younger kids to do this: complement, 90 minus the angle measure, supplement, 180 minus the angle measure. And so this one would be 140 degrees. Okay. 90 minus 77 is going to give me the complement. So that's 13 degrees. 180 minus 77 gives me 103 degrees. So that's the supplement. Okay. Sometimes you can't do it. Okay. 5 pi over 6, right? 5 pi over 6 has got to equal pi over 2. So plus something is going to give me pi over 2. This is not going to work, okay? Because 5 pi over 6 is greater than pi over 2. How I know that? By looking at it. If you make these have common denominators, so if I multiply this by 3 and 3, I get 3 pi over 6. 5 pi is bigger than 3 pi. So you can't do that. Okay. If I want to do the supplement, 3 pi over 6 is, this one's got to add up to pi. This one's got to add up to pi. So 5 pi over 6 plus x has got to equal pi. Again, I'm going to make this have the same bottom. Okay. It just makes seeing it easier. Plus some number is going to equal 6 pi over 6. Okay, hang with me here. To turn a 5 pi into a 6 pi, we have to add 1 pi, not just a 1. Okay, this plus 1 is just 5 pi plus 1. So 5 pi plus pi equals 6 pi, and the bottom has to be the same. Okay, fraction rules. 3 pi over 5 is bigger than 3/5 over 6. Is that right? That doesn't seem right. Hang on. Let me look at this one really quick. Let's make common denominators here. So if we need a common denominator of a 6, that's going to be multiplying everything by 6. So 18 pi over 30. And then this one would be multiplying everything by 5. 15 pi over 30. Yeah, okay, that's what it is. It's just written wrong on here. So 3 pi over 5 is greater than pi over 2. So you can't do that one. Again, you can always convert it to degrees and look. If it's greater than 90 degrees, it's not going to have a complement. Okay. This time, plus a number has to equal pi. So again, common denominators again. I need a 5 on the bottom. So 3 pi over 5 plus x is going to equal 5 pi over 5. 3 pi plus 2 pi is going to give us 5 pi, and then we just keep the denominator. Okay, last page here, arc length. So for a circle of radius r, a central angle, theta, this is theta, and this is the radius, r. This is a radius. Intercepts an arc length of x given by. So this measurement from here to here is your arc, okay? A circle has a radius of 4 inches. Oh, where the angle is measured in radians. Okay, and then we can use this. The arc length is going to equal the radius times the angle measure, again, in radians. So a circle has a radius of 4 inches, so r equals 4. Find the length of the arc intercepted by a central angle of 240 degrees. So we know our angle equals 240 degrees, but I need that in radians. So I'm going to multiply it by pi over 180. Okay, so I'm going to do 240 over 180. That's how I'm going to simplify that fraction down. 4 over 3. So this would be 4 pi over 3. That's your angle measure. So if our formula is S equals R times theta, we're looking for S. Radius is 4 times 4 pi over 3. Okay. 4 times 4 is 16. Keep the pi. Keep the bottom. That's going to be the arc length in inches because that's in inches. Okay. All right. A circle has a radius of 12 millimeters. Find the measure in degrees of the arc with a length. Find the measure in degrees of the arc with length 16 millimeters. Okay. So we know the radius is 12. We know the arc is 16 pi. So S equals R theta. S is 16 pi. Radius is 12 times theta. So we can divide both sides by 12. This is going to simplify. So pi is going to equal, or theta is going to equal 16 pi over 12. We can simplify this though. We can divide both by 4. So 4 pi. 4 pi over 3. And then if we want to convert it to in degrees, times 180 over pi. This would be 3 times 90. So the 3's cancel, the pi's cancel. 4 times 90. That's still not right. Hang on. So if we do 4 times 180 and we divide it by 3, it's 240. Okay. What did I screw up there? 180 divided by 3. Oh, 60. Sorry. That should be a 63 times 60. 4 times 60 is 240 degrees. All right, last thing. As for a circle of radius r, the area A of a sector of the circle with a central angle measured theta is 1/2 r squared theta. That's the area of this piece. Okay? That's what it's finding. So a sprinkler in a golf course fairway sprays water over a distance of 70 feet and rotates to an angle of 120 degrees. Find the area of the fairway watered by the sprinkler. So the radius is going to be 70. The angle is going to be 120 degrees. But again, we need to convert that. 120 times pi over 180 is going to equal 2 pi over 3. Okay. You've got to be able to simplify these fractions down. Okay. A equals 1/2 r squared theta. So the radius is 70 squared times 2 pi over 3. So I'm going to do this first. I'm going to do 1/2 of 70 squared. So 1/2 of 70 squared is going to give me 2450. So I've got 2450 times 2 pi over 3. Okay, so here's how I'm going to do the math on this. 2450 times 2 over 3. And I'm going to go ahead and set it up like a fraction. 2450 times 2 over 3. Okay, 4900 over 3. So that means 4900 pi over 3 is how you would write that. And that's feet squared. All right, and that's it for these notes.